In this project I will show you how to build a proper ARIMA model from scratch using R. I will also load the forecast package and show you how to use the auto.arima function to generate forecasts in an automatic way. I will use Python 1.70 as my IDE, which can be downloaded from here. You can also download my project from the following GitHub link. In this project I will load a time series with energy production numbers in gigawatts hour for an electricity generation company in Argentina. In Python, the data frames are shown next to the panel that created them, as you can see here. This is my time series. I want to show you very quickly how the automatic way of doing this would look like. The forecast package in R has an amazing function called auto.arima. It allows us to find the best model out of a series of many models. I prefer to decompose this series to see what's inside before calling it to check if there are any warning signs. The seasonality pattern is clear. There are no weird outliers. I am not very happy about the trend. An I series to forecast should have a clear trend. This one is choppy and irregular, likely reflecting weird dynamics that we won't be able to capture. Anyway, let's run auto.arima. This function calculates many ARIMA models and chooses the one that's best. In order to define best, it does comparisons based on the Akaike criterion. Basically, every statistical model has an associated Akaike number, and it chooses the one with the smallest value. The theory behind Akaike is somewhat complicated and I won't discuss it here. Let's see the model. I don't like this. There are two parameters, AR1 and AR2, the two autoregressive components that have confidence intervals that include the zero. This means that our model is over-parameterized, meaning it has more things than it should. We always should prefer models with simpler structures. Finally, we can see that the residuals don't have any kind of structure using a Ljungbox test. The p-value is 0.33, meaning that the null hypothesis is accepted. The null hypothesis here is that all correlation lags in the residuals are statistically not different from zero. We probably would like to see if the residuals are normal or close to normal, but I will omit that part here. So overall, I like this model, but the fact that we have extra parameters in here makes me nervous. It means that our model forecast will have wider confidence intervals than what I would like. This is a general idea in statistics. The more garbage we have in a model, the less confident we are in its predictions. My main point is that while these auto-forecast tools are beautiful, they lack the same flexibility as we would have in manual models. Okay, so I will do a 100% manual approach. I first plot the series. I am looking for weird outliers, trends, different volatility patterns, etc. There is nothing much in here. I could obviously complement this with the decompose function I showed a minute ago. Since I know there seems to be a negative trend, I will clean it from the data. I will estimate this trend using the lm function, and then I subtract the trend from the data. Now I look at the ACF and PACF of the residuals. This is the autocorrelation function and the partial autocorrelation functions. Both are used to identify the order of the ARIMA model that I need. First, the series seems to be stationary. If it wasn't, the ACF would decay very slowly, and that is not happening. Obviously, there is significant correlation of order 12 that I want to capture. Remember, this is monthly data. And then, to be absolutely honest, I have no idea what model to fit below a 12 lag. I know I need a 12 lag, but I don't know what should be below it. I see there is some structure at lags 1, 3, 7, I am not sure which AR or MA terms I need. I will first fit an ARIMA model with 6 lags on the moving average part, the MA part, because I would expect the ACF to decay slowly and be more regular if the AR terms were dominating. I think MA terms, moving average terms, are dominating instead, but that's just my suspicion. I use 6 MA terms here and 1 lag at 12-month periodicity. Note that I am not differencing the series, since the series seems to be stationary. As I said before, the ACF decays very slowly. Okay, now look at the parameters. Many of them are garbage, including the zero. Not a problem. I will impose some restrictions using the fixed parameter by setting them to be zero. Nice. Now I have all the coefficients that are statistically significant, meaning they are statistically different from zero. I am now looking at the residuals of the model. There is no significant structure remaining, and they seem to be normal. I can confirm because the histogram looks okay, and then the test does not reject the null hypothesis of stationarity at the 0.49 level. I could add a new test here. Let's assume I want to block the 5th MA term and I want to put it as a 0 in order to simplify and have a simpler model. The lags look okay to me. Maybe the lag at 12 months got slightly bigger. We can use the AIC criterion to choose between different models. Here we got a bigger one, so that's another reason to drop this model and continue with the original one that I just did. Finally, I want to predict this. We call the predict function and we pass the model. The only difficulty is adding the predictions for the trend. Remember that we had previously discarded the trend, so we need to add it back. This is simple. I just create an extension to my original dataset and it's finished. I created a data frame here to show you the trend plus the ARIMA prediction and the combined total. Conclusion. The AIC, the Akaike criterion, on the auto.arima model was much lower than the one that I had with my manual model. That is kind of reasonable because auto.arima scans all possible models and grabs the one with the best AIC, so that shouldn't be a surprise. So on the basis of the AIC, the Akaike criterion alone, we could argue that the auto.arima is beating my model. However, because it has statistically not significant terms in there, it's not that great. Which one should we prefer? Nobody knows. I personally prefer the manual one. Having terms not different from 0 should always make us worry. Unfortunately, a lot in forecasting is more of an art than science and really depends on your personal taste.